Exercise 1.1, question number 1. Use Euclid's division algorithm to find HCF of Roman number 1, 135 and 225, Roman number 2, 196 and 38,220. So we are going to solve Roman number 1 first. So in case of Roman number 1, 225 is greater than 135. So in solution we write, since 225 is greater than 135, so we have to divide 225 by 135. 135 is the divisor and 225 is the dividend. So 135 will go in 225 one time. So we write 135 here. After deducting it from 225, we get 90 as remainder. Now this remainder 90 becomes the divisor, and we are going to divide the previous divisor 135. Now 90 will go in 135 one time, so we write 90 here. After deducting it from 135, we get 45 is the remainder. Now this remainder becomes new divisor and the previous divisor becomes dividend. So 45 will go in 90. How many times? 2 times. So we write 90. So 90 minus 90 is equal to 0. After dividing 90 by 45, we get the remainder is equal to 0. That is why the HCF of 135 and 225 is equal to 45, which is our answer. Next, Roman number 2. In between these two numbers, so 38,220 is greater than 196. It means that we have to divide 38,220 by 196. If you check, then you will get 196 will go 195 times, then to make 38,220. So if we divide this 38,220 by 196, then quotient we shall get as 195 and remainder becomes 0. So as we divide this number 38,220 by 196 and becomes remainder is equal to 0, so 196 will be the HCF, that is highest common factor of these two numbers, that is 196 and 38,220. That is the HCF of 196 and 38,220 equal to 196, which is our answer. Question number 2. Show that any positive odd integers is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integers. So let us start the solution of this question. Solution: let a be any positive integer and b is equal to 6. Where b equal to 6? You see, the integers are of the form 6q plus 1, 6q plus 3, 6q plus 5. So in this place 6 is here. Here 6 is the value of b. So b is equal to 6. And r is always greater than or equal to 0 and less than b, that is the value of b is 6. If r is greater than or equal to 0 and less than 6, then the value of r must be 0, 1, 2, 3, 4 and 5. Therefore, using Euclid's algorithm. What is Euclid's algorithm? Euclid's algorithm is a equal to bq plus r. A is equal to dividend, b is the what? Divisor, q is the quotient and r is the remainder. So what is the divisor here? 6 and here is q plus what is the value of r. We are taking first value of r is equal to 0, then 6q plus 0 is equal to 6q, which is our Roman number 1. Similarly, by putting the respective values of r, we can find out the value of a. We can find out the value of a. Suppose a equal to 6q plus 1 because r is equal to 1. Similarly, a is equal to 6q plus 2 because the value of r is equal to 2. A is equal to 6q plus 3 because the value of r is equal to 3. A is equal to 6q plus 4 because the value of r is equal to 4, and a is equal to 6q plus 5 because the value of r is equal to 5. Here 6 is the value of b, and 0, 1, 2, 3, 4, 5 are the values of r respectively. Now according to questions, we have to find out only the positive odd integers. So what are the positive odd integers? From here if we look, only the positive odd integers are 6q plus 1, 6q plus 1, 6q plus 3 and 6q plus 5. So finally we write any positive odd integer is of the form 6q plus 1, 6q plus 3 and 6q plus 5, which is our answer.